Hello everyone and welcome back to another video. First off, I want to start off with saying thank you so very much for the continued support. I wasn't really thinking that there would be a possibility that I could reach 100 or even 200, let alone 300 subscribers. So let me start off by saying thank you so very much for your continued support, and I hope that slowly and steadily I am going to continue slowly growing so that I can give you content more often in just the general type of stuff that you would enjoy watching. So today's video was actually supposed to be something a little different. Going off of the last video when I talked about different cabling types and the purposes of all the connections that I've had, I wanted to, in the current video that is right now, I initially wanted to talk about iSCSI setup through the different operating system operating file sorry. me me oh man. Anyways, the purpose of this video was actually supposed to be something completely different. I wanted to talk about setting up iSCSI in Windows Server, and then setting up iSCSI in a true NAS file server, and then setting up your physical server to boot off of a iSCSI volume. However, due to logistical issues, in other words, I'm stuck at work over the weekend, so I don't really have plenty of time or plenty of opportunity to go back home, and I don't have access to my servers. I am going to do something a little different. And, because I've already spoken about how we're going to slowly do a dive into the more theoretical, quote unquote, stuff with software setup and so on and so forth. We're just gonna bring it up from up the schedule, and we are going to proceed with that. And then when I have the chance to go back home in the garage and actually have physical access to my servers, I will do another video talking about iSCSI setup through the different operating systems. In either case though, it's not very difficult, and once you set up iSCSI and you understand the principle behind it, it becomes sorry, this cough has not let me go for like the past 3 weeks, and it's starting to annoy me. But as I was saying, once you understand the principle of setting up an iSCSI volume and then mapping your device to an iSCSI volume, then you're pretty much solid. It's almost operating system independent, meaning that the settings are universal. But the plan for now is, because my whole family stores data onto the file server that I want to use as a victim, I'm just waiting to potentially get sorry, I'm just waiting to potentially get a small NAS, transfer all the family data onto that, put it behind the TV, so that I can have unobstructed access to the file server and reinstall it and reset the VDEVs and the volumes and just do whatever the hell I want with it. So on the screen, as you guys can see, I have set up a small template, just 5 basic virtual machines. One is going to be acting as your router, which is the PFSense demo. One is going to be two of them are going to be acting as client, but on different operating system basis. One is your Ubuntu client and one is your Windows client. The third one that we're putting is Windows Server, so that's something that's going to be providing a service. And last but not least, it's going to be the the virtual machine that's hosting our TrueNAS instance. For reference, the virtual machines that I have set up are as of August 17th, I believe, 18th. As of August 18th, the operating systems are either the latest release from their respective manufacturers, so Ubuntu 23.04, Windows Server, and Windows 10 Pro updated to the latest cumulative update, and TrueNAS latest as of August 18th. And PFSense is, I believe, 2.6, 2.7. Anyways, we're gonna have a chance to double check on that. So in what I am going to do is I'm gonna open the remote window to Windows client, because everybody is familiar with that, and we're going to use the Windows client to navigate into our both in our router and into our file server. I have not I have not purchased a key. I am literally using this into the demo version, and this should already have the interesting. This should already have a okay, hold on just a second then. So instead of power virtualizing it, this should we are going to change this to Intel E1000. Sure. I thought maybe the MAC address would be changing, but let me. No, I am. Okay, cool, excellent. So let's just fix that real quick and go back into Windows, and there we go. Now we have connectivity into our network. So sorry, let's just backtrack a little bit. One thing that I did forget to mention is how I have the network in Proxmox laid out. If we go under the server that I have and then under network, you're going to see that I have two virtual interfaces. One of them is the one that's bridged to my physical local network, and then another bridge that is just not connected to everything. So this right here is going to be acting as an as a internal virtual switch, to which I'm all going to be connecting all the virtual machines that I'm connecting to Proxmox, and then VMBR0 is going to be acting as the wide area network interface, or quote unquote the ISP. So stupid cough. Anyways, now that we have that taken care of, let's go back into our Windows client, and we're going to open up a browser. So the purpose of this video again is we're going to be talking a little bit about PFSense. We're going to do a basic domain setup just with PFSense. We're not going to be going over the we're not going to be going over to create a domain controller just yet. We're going to do that a little bit later, potentially tomorrow or the day after. But now that I overall have another server that I can work with, I can actually create videos a little bit on a more dedicated on a little bit more dedicated fashion, rather than waiting to go home into the garage every weekend. So I can manipulate the sorry I can manipulate the recording times a little better. So the default IP address for PFSense is 192.168.1.1, and if I remember correctly, I literally did this morning. It's the default username and password are admin and PFSense, and then it's whatever you set it up on your first login. So we are Sorry, we are running PFSense 2.7, and as I said, as of August 18, it is the latest version that is available on Netgate's website. So our first stop is going to be the system and general setup. So this is where we're going to be configuring the host basics, just such as host name, the domain, and DNS servers. So one of the things that I like to do is when I have an instance of PFSense or in a type of network that I'm designing or that I'm creating, is I am going to call it literally just gateway, and then in the domain it's gonna be oh man, listen, for the sake of argument, let's call it home.com, because actually no, not home.com, because my office.domain, I guess. Sure, let's just go with that. And another thing that I will do is I will add another DNS server. So we're just going to move those one step down, and the way the DNS server settings for PFSense works is in a sequential order. So if we scroll down just a little bit further down, and we're looking at the DNS resolution behavior, as you can see, it says use local DNS 127.0.0.1 and then fall back on remote DNS servers, which is by default. Basically what it means is that it's going to check its own internal tables to see if what you're looking for can be addressed by the PFSense router, and if it cannot, then it's going to reference sequentially the first DNS server. If the first DNS server doesn't have it, then it's going to go to the second, and if the second doesn't have it, it's going to go to the third, and you know, etc., etc., for the amount of servers that you have listed. Sorry about that. In a perfect environment, just to avoid DNS leaks, you want to have DNS server just from one company. Meaning that if you're, for example, using Cloudflare as a DNS backup solution, then only use Cloudflare DNS servers as a backup, and do not mix it with Cloudflare, Google, Microsoft, because that creates a DNS leak. Rather than, if you're choosing Cloudflare, only go with Cloudflare. If you're choosing Google, only go with Google. If you're choosing Microsoft, only go with Microsoft, and so on and so forth. So in this box right here, the IP that we're reserving it is going to be the future IP of the server that is going to be acting as our Active Directory. So for my case, because I really don't want to mess around with it too much, I'm just gonna set it up and forget it. So we're just gonna go into my Windows Server demo that is going to be used as a Active Directory server further down the line. And as soon as I find out the IP, we are just going to set that IP, and we're just going to continue on with the video. So the IP for this server is come on, please load faster. Oh man, it just really doesn't like the para-virtualized. Okay, no problem, no problem. So in my case, what it is that Windows just doesn't like VirtIO, and it prefers Intel E1000. Okay, no problem. We're just gonna set it back to E1000, and we're just gonna fix that right now. And then we're gonna go back into the console. We're gonna have our network, and CMD, and then IP config. And the IP that we're going to be looking for is 1.101. Perfect. Okay, so let's go back into our Windows client, and then we're gonna put 168.1.101. And like I said, this is gonna be what's acting as our internal Active Directory server, and I'll tell you why later, why we're putting this. It's not going to be later in this video, but it's going to be later in the video where we actually set up Active Directory to work with our network. And then we're going to scroll down, we're going to select our time zone. I personally prefer the ntp.org server, so I leave it as is. If you guys have a different preference, you can just go ahead and you know, fill out your details over here. So now that that's all done, we're gonna click on save. It's gonna put us up to the top of the page in just a second. Okay, and then we are going to go down into system and then click on advanced option this time. So in a perfect environment, you are going to have a certificate. Because the system is using it self-signed, it's automatically selected HTTPS. However, you will notice that your browser is going to continuously say, this is not trusted, this is not trusted. If it's a network that's not really connected to the internet, it's something that's completely virtualized, feel free to ignore it. Don't worry about it, simply because you are in control of that network, and because it's an internal, fully virtualized network with no outside access, you don't have to worry about man-in-the-middle attacks or intrusions or anything like that. So just, you can leave it as is with the certificate that's already pre-selected. And then in a further video, we're going to address SSL TLS certificates on PFSense when we decide to make it available through the internet. I personally get rid of the web GUI login autocomplete. I leave the anti-lockout rules because it has happened a couple of times. And then if I really want to mess around with SSH, I can enable it. Otherwise, I don't really need it. And then that's pretty much it for and that's pretty much it for the settings in the first page, because serial is not really enabled for me, so it doesn't really matter what we do. After that, we're gonna go into the firewall and NAT tab, and then what we're gonna do is we're going to take a look at the settings. For the most part, the default, we don't really change the default because it's quote-unquote auto-detected by what your hardware can do. So for me, because I have created a fairly weak virtual machine, 2-core, 4 gigs of RAM with a 64 gig storage medium, you know, I'm not really gonna go ahead and change any of the sorry, I'm having a brain fart. Any of the default values. The only thing that I do want to take a look at is NAT reflection mode. I'm going to put it into pure NAT, and then scroll down to the bottom, click save. Wait until the page refreshes, go into networking. I usually, in my garage, I have gotten rid of IPv6 simply because the ISP that I'm using just doesn't support IPv6 just yet for small business or personal internet plans. So it really just have no purpose of having it. In the next tab, which is miscellaneous, if you have a Intel Quick Assist technology, I think that's what it's called, QAT, for a cryptographic support card, this is where you would enable it. So you click on cryptographic. There's gonna be another option that pops down, Intel QAT. Now, whenever you guys go and add a QAT card, something to notice that when I added my QAT card, It wasn't available for selection until PFSense Plus 2205 release. Sorry, release correction. I think that's what it's called, or subversion 03. So out of the box, it was not readily available for use. I had to update PFSense a couple of times until I got functionality of my QAT card. So if you potentially have a QAT card into your system that you're going to be using for VPN acceleration, do not panic, because it is just mostly the most probable thing that is happening right now is that the operating system, in other words, FreeBSD has just not installed the driver for it, and you probably just either need to reboot your system or perform updates. Once that is done, most probably your QAT card is going to become available, and then this is where you're going to select the option. What ends up happening is that Intel QAT just allows you to have near line speed VPN speeds, which if you're working remotely or you need constant remote access to your network through a VPN, is a godsend. Trust me on this. So scrolling just a little further down, we don't touch kernel PTI. However, MDS mode, we just select the automatic VERW or software selection, and then once all the just make sure that the hard disk standby time is not a numerical value, but instead is always on. That way it doesn't go into standby or sleep mode. In other words, it doesn't put your router to sleep when there is 0 to no activities. And then system tunables, I don't really do anything with, and notification, I just turn those off, because realistically I do not use anything in terms of notification when I am with my system. So the next step is essentially the big step that we really want to have a look at when we're talking about having your PFSense router have full control over the network, and then knowing how to direct a type of inquiry from one computer to another. For example, whenever you in a Windows machine or in a Ubuntu machine, you type // whatever the name is of your file server. So a // file server, you want your file server to respond with a DNS with its DNS name. So what you want to do in this case right now is that you're gonna go under services and then under DHCP server, and you're gonna, if you have multiple networks, you're gonna have to make sure that you select the proper network that you're gonna be using on. And then if you scroll down just a little bit, I think this was the place. Oh yes, so you want to enable the static ARP entry. Basically what it means is that whenever you are going to be addressing whenever you're going to be addressing a host by its domain name, okay, basically what that means is that PFSense is going to check its routing table and to see if there's a domain name or a host name associated with the target. In meaning that, for example, when I open command prompt over here and I type in ping GW, as you can see, it is automatically replying as a full domain name, gw.myoffice.domain. That is extremely useful for bigger networks, which that have significantly large scopes, like a /23 or potentially even a /22, and you're more familiar with the administrative side of the network by DNS rather than by IP. So like, for example, if you do sorry, not pig, but we're doing pig 192.168.1.1, PFSense will still respond, right? But if you only know it as its domain name, which is gateway, you can say ping gateway, or in this case, ping gateway dot myoffice dot domain, and it will respond with its full domain name, and that is going to be true for all the hosts in your network, especially when you go and start setting up Windows Active Directory. And again, instead, I know I am getting a little ahead of myself, so please just be patient. This will come incredibly this will come in incredibly handy whenever we are going to be doing the DHCP DNS section of our network, when we start setting up our Active Directory for us. So for now, leave that option enabled. And sometimes, if you want to do a little bit of added security, there is an option. I have to find it. But basically, what it does is, if you're even though you have a device connected to your network, if you do not have that device listed in your static ARP table, it will not gain connectivity to the network, even though it receives IP. That is potentially useful for oh man, what are these called? Like captive portals and just open networks in general. Something that you want to control, like for example, friends or co-workers or whatever who do a lot of BYOD, bring your own device. Once you add that device to the network and set it up into your static ARP table, it will have access to PFSense, and it will have access to the network and subsequently the internet that the network is connected to. However, if you have a device that is not explicitly listed into that ARP table, it will not work in terms of connecting to the network and having access to the internet. It will still receive an IP. Honestly, I don't know why it works that way. I have to do a little bit more reading in terms of why the device would still quote unquote connect to the network and receive an IP from the DHCP server on PFSense. But you can rest assured that if I will find that option, and I will let you guys know. If I don't do it in the video, then I will do it in the video description. Sorry. Anyways, so let's just continue with the next option. I think DNS, the DNS forwarder is the one that is not used, but the DNS resolver is the one that we want to use. So for the most part, we are going to leave all the options as static. However, the only one thing that we are going to select is register DHCP leases in DNS resolver, and this is the option over here. And we're gonna register OpenVPN clients. That's for just the future. So this is the option that I was telling you guys. That's an extra layer of protection. This is the option if you want your network to be to have just an extra layer of security and only have devices which are registered with your static ARP table. Select this option, and then basically what this option means is that if your device that you're trying to connect is not listed in your DHCP static mapping, it will not have access to the network or the internet or any of the resources that the network offers. So you know, it's just an extra um, layer of protection and a layer of administration that if you suspect that there's bad actors on your network, you can enable that option and filter them out based on which device has access to the network and which device doesn't. So now that we have done that, we are going to click on save, and we are going to go up and click apply changes. Sometimes it will not take effect right away. It might need up until the next DHCP renewal to take effect. However, for the most part, 9 out of 10 times probably, it will take effect right away. If I remember correctly, under advanced settings and the last tab in the access list, unless you have something specific that you want to configure here, we don't really have anything to do. And then we are going to go under services, and we are going to go under dynamic DNS. So for dynamic DNS, I personally use Cloudflare with my network to keep my wide area network IP up to date, and it's really easy to set up. So under the service type, you're going to go under Cloudflare, not the v6 option. When the interface to monitor, you want it to be the wide area network. This is usually the interface that's connected to a modem and going outside. You're gonna put the host name, so subdomain at domain.com. In basically what it means is that, for example, if you have a web server, that web server dot mydomain.com is basically what that means. Okay, that's all. Then you're gonna enable the Cloudflare proxy. You're gonna input the username, the password, and the password over here. If you just take a look at the notes, that's being underlined for Cloudflare. The password for this to work is actually the global API key for the account. All right. So once you have that, you are going to click on save, and your DNS will be up to date with and synchronized with Cloudflare. Next thing that we're gonna do, we're gonna skip IGMP proxy because I really don't want to deal with it right now, and then we're just gonna go over to NTP. So when it comes to networks, having a accurate time reference is very, very important, because a lot of operations are time dependent. So like, for example, if you're running a game server, the time of the game server, or if you're running a transactional server of time of some kind, it is very important to have a time synchronization. Like I mentioned earlier into the basic settings, I prefer to leave it as is. And in a perfect scenario, what you would like to do is just select a pool altogether and just leave it at that. Because basically what it means is, in a pool, there's going to be multiple hosts that are working. And if there's one host that doesn't respond, the pool will automatically select the first available working, or the first available serviceable host to service your query, and it will give you an up-to-date time. If we scroll further down, there's not really anything that we require with the small exception that if your NTP server that you're trying to connect to requires v3 authentication, this is where you come in and you put that information in. Okay, so if you have a serial GPS, which is a oh man, what was it called? Oh man, there was a name for it. Stratum. Okay, Stratum. Basically what it means is your if you have a GPS clock, which by the way those things are extremely expensive, but they're extremely expensive because they're extremely accurate. And this is where basically you're going to be setting up the stratum 0, or yeah, stratum 0 GPS clock, and then PFSense is going to be taking its clock reference on top from that GPS clock. Anyways, we don't really have a GPS clock that we want to connect to this virtual machine, so it doesn't really matter. Next up, we're gonna do UPnP and network address translation PnP, port map. I forget what it stands for. Sorry, it's been a hot minute, but basically this is like the Apple stuff, which if you have an Apple device, then it concerns you. If you don't have an Apple device, then it doesn't really concern you. So if you need UPnP, which is Universal Plug and Play, which basically means oh man, sorry, I'm definitely having a brain fart. Meaning opening ports on the fly, depending on use case scenario. So like for example, if you're downloading torrents, UPnP takes care of the automatic port mapping and opens the port during the download, and then as soon as the download is complete, it closes it. If you have a console, whether it's Xbox or PlayStation or Nintendo, whatever it is, or whatever, when it's accessing game servers and you are playing online, open ports do give you a little bit of better traffic, and this is where you set it up. So basically you're gonna enable the UPnP function, and then you're gonna enable mapping. You're going to leave the defaults, because normally the defaults, unless you have a specifically complicated network, you don't really need to change it. The interface is as is. The download speeds, if you don't put anything here, it's just going to use the maximum. However, if you put something in kilobits per second, it's just going to set it at that maximum speed. You can log packs and use the system uptime instead of the port map uptime, which really is personal preference at this point. However, the important part is that you wanna enable the stun server. Basically what it means is that, because essentially everybody is behind a NAT service, meaning that they have a bunch of local IPs and then one public IP, and that's how they access the internet. And then when the internet returns a response, your router knows how to map the destination of that response. So the stun server is basically just to make sure that your external IP is properly synchronized with that mapping, so when the data comes back for whatever port mapping it is that you might have, it just makes sure that the external IP is properly mapped. I personally use the Google Stun server, so literally the information is right here. So you're just gonna copy paste this into this box right here, and then port 19,302. You're gonna fill it out over here, and then whatever, it's gonna work. And then very, very important, what you want to do is that you want to enable this option if you're gonna go with UPnP, basically meaning that unless UPnP is enabled, it will deny it, which is basically the same thing as when you're not using UPnP. So actually I have to do a little bit of reading on this, because now that I think about it, it is a little confusing to me. I will do a little bit of reading and I will get back to you guys on that. So that being said, we're gonna just disable this service because they don't really need it. and then we are going to go to basically the last part, which is going to be just to monitor the DHCP leases. It's not really something that is mandatory, but at this point it's just for verification purposes. So we're going to take a look at all the host names, and we're going to open whether it's going to be a command prompt or a terminal window, and we're just going to make sure that we can ping all these host names. Well, I'm not really going to use the last host name because this is just the Ubuntu client, which is fine, I trust it. But we're gonna do ping TrueNAS. Okay, TrueNAS response with the proper IP. We're going to ping a Windows server, which is desktop BJL RN9K R9K response, and look at that, it actually even responds from its IPv6 address rather than its IPv4, which is perfect. Then we're going to do ping win-887 VGNG KQ98. Okay, hold on. 887 VGNG KQ98. Maybe this one is case sensitive. So win-887 VGNG KQ98. Oh, so this is the Windows Server one, and basically what that means is that we're gonna have to come here and then Windows Firewall with advanced security, right? For this to work, we need to come into our Windows. Wait, no. We're just going to turn all the firewall profiles off because I'm not sure which one it's using right now. And then we're just going to re-enable it after. Okay, so then we're going to come back here, and then we are going to ping it one more time, and then there it is, it responds. So that's perfect. And then really, if we really want to do semantics, we're gonna ping demo standard PCI 440FX-PIIX-1996, and then this one also responds. So the DNS server on our PFSense is mapping everything correctly. So far everything responds and works as it should, and we are essentially we have just finished setting up our PFSense to be a involved controlling body into our network, so that we can have advanced DNS capability internally. So when we go into the next video, we are going to we are going to have a look at how this helps us, especially when we have a Active Directory or an advanced domain environment, and we're gonna have a little bit of a chat about that. So far, I want to thank you again for tuning in. I know this is not really the super exciting video that we normally go through and show off different types of hardware, but at some point this was going to come, and learning how the inside part of your environment works is just another stepping stone on the road to success, I guess. Whatever. Anyways, thank you so very much for tuning in. Thank you again for the continued support, and I will see you guys in the next video. Bye for now.